Hello everybody! Today I'm going to go over how to set up one of these, an off-axis guider. I know many people like myself have had difficulty setting these things up, and many people have ended up going grey prematurely or even ended up in a straitjacket over it. What we're going to do in this session is show you a method of setting this up that's pain-free and that I've learned the hard way, and I hope it's going to be useful to you. Welcome to Astrogadge. So why use one of these things? Why not just stay with a guide scope attached to a guide camera that you probably got at the moment? Well, the answer is quite simply this is a much more accurate method of guiding, because essentially you're using the one telescope to produce an image in both your main camera and in your guiding camera. And that avoids factors such as differential flexure, which can occur if you haven't got your guide scope tightened up enough, or that the guide camera is slightly loose. There's all these factors that can cause slightest movement in your guiding, which will throw your entire imaging session off. If you're imaging using a telescope with a focal length of say 2000 millimeters or greater, then these things are pretty much essential, because any guiding error when you're imaging at this focal length is much less forgiving than it is if you're using a shorter focal length, say with a small focal length refractor. Let's go and have a look at the method I used, that I learned the hard way, and I hope it helps you. Let's go. Here is our off-axis guider, and essentially it's a pretty straightforward but effective design. What you have here is a prism or mirror system which allows light from the telescope, or some of the light from the telescope, to hit the prism and then bounce up here through this hole to the guide camera. The remainder of the light simply passes through to the sensor of the imaging camera. So you don't need two separate telescopes for guiding. You're essentially using the one telescope for imaging and guiding. This screw here and this grub screw here need to be loosened off so that you can actually, once you have your guide camera attached, you can effectively focus the guide camera, and essentially do that by moving this saddle up and down until you achieve focus. And once you achieve focus, you'll lock the relevant screws, and once it's locked it should stay in focus. That's the end of it. This screw here adjusts the height, the position of the prism relative to the central opening, and that's important. This adjustment is very important. I'll explain why in a minute. The main thing I've heard, or the issue that people have with these is, you know, from reading various things, that they say, look, I attach this to my imaging ring and I simply can't get an image. I've tried everything. I'm pulling my hair out and I'm throwing the thing in the bin and going back to my guide scope, because I just simply can't get an image. And invariably it turns out that they've got the thing the wrong way round. So which way round should it be facing? So, well, the answer is very simple. If you actually look at the OAG, you'll see that the prism has a flat side here, and it also has an angled side at the other end. The thing is, the correct way it should face the telescope is always the flat side of the prism, the flat side of the prism always faces the telescope. If you turn it round so the angled side faces the telescope, you will not get an image at all. And I think that is the main problem that people encounter when they have difficulty getting the thing to work. So, just to reiterate, flat side telescope. So you can see this quite clearly. If you're not sure, just simply look down the off-axis guider like so. So put yourself in the position of the guide camera, and it's just simply a question. If you wiggle your finger in front of the prism, you'll see an image of your finger in it. Okay, see that there, I hope. So if you're not sure, that's the simplest way to do it. Like I say, if you turn it that way around, nothing's going to happen. You just simply not get an image. So a lot of people fail at the first hurdle. Like I say, make sure you've got the thing orientated correctly. Otherwise, nothing's going to happen. So, and the off-axis guider. Remember, this is the side, the flat side, that faces the telescope. Simply slots in here and is locked. Slots in, simply slots in like so, and is locked in position with these retaining nuts. So here is the OAG connected to the filter wheel and the Attic 460, as well as the ASI 120 monochrome camera for guiding. Now, if you're using this setup with a refractor, it's really important that you're using a field flattener with your refractor to correct the star shapes at the periphery of the field of view. It's really important that you follow the manufacturer's stated optimal distance between the off-axis, between where the field flattener connects to the actual sensor of your imaging camera. A lot, if not most, of the telescope manufacturers of refractors who use field flatteners give a distance of about 55 millimeters. And in fact, in the case that I'm about to show, that yes, that's a quoted difference for the field flattener that I'm using on the Williams Optic ZS 61. So that means I have to make sure that the distance between the edge of the off-axis guider, the flange that fits onto the field flattener, to where the positioner of the sensor on the imaging camera, that distance is 55 millimeters, or as close to that as you can get. In order to do that, obviously what you need to do is measure the width of your off-axis guider, in this case the filter wheel, and in this case the back focus of the Attic 460EX is 13 millimeters. So 13 millimeters from here to here to give a total of 55. Alright, so in order to do that, I don't know if you can see in this too well, I've had to use some spacers here. I know what the distance of these are. So it's now set up to give precisely a 55 millimeter distance between the field flattener and the sensor of the main camera. This is where that information is important regarding the focus of your guide camera is. So since the distance between field flattener here and the sensor and the imaging camera is 55 millimeters, I need to make sure that the distance between here, where the prism is, to the sensor of this camera is also 55 millimeters. Otherwise we won't get a clear image. So again, this is the thing you need to check. Now, it's not the distance between the center and the sensor of the camera. It's this distance between the prism and the sensor that's important, because as I said, you're going to adjust this up and down anyway depending on your imaging camera. So it's the distance between here and the center of this camera has got to equal the distance between here to the sensor. Okay, so that has got to equal this. Okay. Now, some off-axis guiders, which we'll talk about later, aren't really designed with that in mind, and I'll show you an example of that. But essentially, what you'll be doing once you get these distances roughly right, that means that any adjustments that you carry out using the fine up and down movement here, once you've unlocked it, you're going to move it up and down. If you've got your distances roughly right, then the amount you have to move this is absolutely going to be, should be fairly minimal. Once you've got that set up, we're pretty much ready to go. In a circumstance where you find that you've not got enough, or you're unable to achieve focus outwards, then this little saddle here is threaded such that you can add spacers to increase the distance if need be. If the adjustment here is not enough, you can add distance on and then readjust using the focus. If you're using a non-refractor type of telescope, such as a Schmidt-Cassegrain or a Newtonian, then there's no need for a field flattener in the same way. So this distance, being 55, is not critical. Okay, the distance is only critical if you're using a field flattener. But either way, you should still check the distance between the flange and the sensor and the saddle, and the prism and the sensor here are the same. It's just that if you're not using a field flattener, it doesn't necessarily have to be 55 millimeters. And that leads me on to just to show you that here's another off-axis guider, but you notice that the stock is much longer than the one I've got fitted, and that presents a problem. When I get 55 millimeter back focus to the camera for use with a field flattener, I cannot get enough forward focus here to get the guide camera in focus. So if you are going to use this with a field flattener, then make sure you get one that allows you to achieve the correct focus. And this particular one here I'm using is, dare I say, is by ZWO, and much as I hate to plug one company all the time, they've designed this whole off-axis guider system to give you exactly 55 millimeters with their camera, or just by adding spacers if it's not with their camera. So the whole thing is actually designed to optimize use at 55 millimeters. The other part of the setup that's really important is to set the distance of the prism so that it's far enough down the opening here, but not far enough to actually impinge on the sensor of the camera, which you can see here. Again, if I turn this slightly, you get a better idea. And this is particularly important when you've got a larger sensor, such as the APC of the ASI 2600 MC. So what you want to do is get this as far down as possible, but not so far that it's going to cast a shadow on the sensor, because that looks really horrible, and you can't really get rid of that using flats calibration. So how you adjust that is very simple. Again, it's simply looking down, as we're doing here, adjusting, loosening the grub screw and the little screw here, and moving the stalk up and down till you get the desired distance. So like I say, you want to get it so it's just beyond the actual periphery of the sensor. And again, when you come to do a star test, or even you could do a test in daylight, it'll become pretty obvious if you've gone too far, but that's what this adjustment is here. So it's very similar to the focus adjustment here for the camera. So don't confuse the two. This is for the focus of the camera, and this is for the distance of the stalk of the prism. If you are using it, as I say, with a non-refractor telescope and field flattener, and you find that you cannot get enough downward focus, then simply add spacers to the back. So if you can't get this closer here, add more distance to the back. Right, so we have our distances roughly correct. I've used an electronic caliper to measure it, which is a useful tool to have in this circumstance. So now it's just a question of coupling it to the telescope, in this case a refractor, via the field flattener, and if our distances are there or thereabouts, we should get an image, albeit it might be slightly blurry to account for the differences and slight differences in distance, but that's where the focus here comes in. So we simply use the adjustments here to compensate for any slight errors in distant measurement. Here is an imaging camera attached to the off-axis guider and filter wheel, which is attached to a Williams Optic ZS61 via the field flattener. Okay, so as you can see, I've got the camera and the OAG guiding camera set up on the telescope, connected to a mount, and if you just see in the distance there to the left of the eaves of the house opposite, roughly in the centre of the image, there's a tree. So that's what we're going to focus on to set our OAG up. Okay, so I have focused the main camera, the Attic 460, on the tree in the distance that the telescope's pointed at. I've adjusted the focus so it's there or thereabouts, pretty reasonable. So I'm happy that we've achieved focus with the telescope through onto the chip of the Attic. So the next step is to switch views to the camera that will be doing the guiding, in other words the camera that's attached to the OAG. So what I've done is I've adjusted the telescope so that this area of the tree in the main imaging camera is now more or less centered on the center of the field of view of the guiding camera. So as we can see, the off-axis guider needs a little better focus on this area. So I actually pushed it in a little bit, so I'm going to move it out slightly now. Almost there. It's just a matter of moving the stem up very small increments until we get the thing sharp. Yeah, I'm happy with that now. So once we've got the focus, it's really just a question of
locking focus using the coarse locking knob and the grub screw, and that's it.
Well, I hope you found that useful. So just to summarise, make sure that you've got the guider orientated the right way round. Secondly, do any measurements and coarse focus checks during the day. And any fine focus adjustments you need to do, just do it using a proper star test. I hope you found that useful. If you like what you saw, please give us a thumbs up and consider subscribing. It's free and it just means that you get heads up on any similar content that I may produce. Before I go, I'd just like to reiterate the fact that I have no financial or any other affiliation to any of the products that I may mention in this video or others. So thanks again folks, and remember, keep watching the skies.
Watch the skies everywhere. Keep looking. Keep watching the skies.